What's going on, folks? Can you hear my voice? Can you see the computer screen? We're ready to go? Let's do a double recording. So I'm recording this to the WebEx archive, and I'm also recording to Snagit. If Snagit works successfully, which it should, hopefully that's the theory, then what I'll do is I will upload it to YouTube and put it in our usual spot. You guys having trouble finding the archives, or are we good? You guys know where they are? All right, just so I know that everyone's here and listening and actually has their audio up, say good morning. Good morning. Chat in good morning to me. There we go. Ramana's here. All right, good, good. Just want to make sure you're awake. Is it cold where you guys are at? Like I'm for freezing. It's pouring. Oh yeah. All right. Anyway, let's start up on this one. I'm gonna go back to quad one. I'm gonna be looking over some of your homework. I noticed a lot of you folks had trouble with some of the homework, and particularly this last one that we turned in last week, Friday. I'm also going to touch up on quad 2 a little bit, because I think that yesterday's homework was a little bit difficult for some of you. Or maybe, like, you had to really think about how this concept works, and once I explained that to you, you're just like, oh, I get it. I'll tell you what, I'll make a deal with you. If I explain these homework assignments to you, because I'm actually going to do your homework in class, that's why I don't accept late homework. But if I explain this to you, I'll let you go back and redo the assignment if you got it wrong. Cool? And if you got it wrong and you redo the assignment, you scan it, put it into the Dropbox, and then email me and say, hey, Mr. Dalday, I redid it. Can you regrade it? I'll be like, all right, sure, fine. Cool? You guys good? We good? All right, good. All right, so I think that on what page was this? This was page 31. I think on page 31, you guys got kind of messed up with foiling. Yeah, I'm in the big room. All right, you guys got kind of messed up with foiling, and the idea of foiling is, I almost want to demonstrate it. Like I had a lot of fun demonstrating it yesterday. So let's do it. Let's do it. Foiling. Get up here, boys. Come on, you guys know what we're doing. All right, come on. Come on. All right. Yes, it's first, outer, inner, last, but here's basically the story behind it. Cool? All right. So I got me and Mitchell. We're over here. We're hanging out. I've got the twins. They're over here. Come on over. So I got me and Mitchell. We're hanging out. We're buddies. You got the twins. You guys get on camera so you can see you. You guys see your pretty face. All right, cool. So say that me and Mitchell are college roommates. And this dorm that we have it fits like 4 people. So we got the twins coming in, and then they're like, hey, you're going to be moving in with us. We're going to have an apartment with four dudes in it. So what we do is we say, all right, so you guys are on the outside. See this purple line right here? That's the outside of the room, and here's the inside of the room. Cool? I'm at position 1. He's position 2. And we're inside. We're a group that's hanging out already, right? He's at position 1, and he's at position 2, and he's the group that's outside. And they want to come in and meet everyone in here. So here's how you do it, okay? The process goes down like this. And I'm sure that once I explain this to you, you're like, oh, this makes sense. Foil makes sense. Okay, first I would do is I'd meet the first twin. What's up, dude? And you are... my name is Mr. Dalday. You are? Window. Good. Awesome. Hey, what's going on? My name is Mr. Dalday. What's your name?
George.
George. Good. Nice to meet you. All right. So I met the first dude here, and then I met the second guy over there, right? All right. Now your turn.
So Mitchell.
There's Mitchell, and that's Window. All right. Let me turn that. All right. Do you guys kind of understand Oh, all right. I was like, what? All right. You guys kind of understand what just went down, and I'll show you how this analogy applies. All right. Okay. Go on. Sit down. Put him in my chair. There it is. All right. So here's the concept. Okay. We got Mr. D. We got Mitchell.
And we're hanging out inside, right? And then we've got George. No, actually, we met Window first. Oh, yeah, Window and George. And
They want to come in and meet us over here. Excuse me. So we want to make sure that everyone meets everyone. We want Mr. D to meet
Window. So we've got D times W. And we want to make sure that Mr. D meets George. So we got DG. Cool. And we want to make sure that the insides, we got Mitchell meets Window. And we want to make sure that Mitchell meets George. GW is the first, because it's the first guy times the first guy. Cool. DG is the outers, because it's the dudes on the outside.
right?
And W is the dudes on the inside. And then MG is the dudes on the end, the last dudes.
In both categories, they're meeting each other. Does that kind of make sense? It's kind of like the distributive property for multiple sets of people. You see what I mean? Like when you have like
X times, I don't know, X plus 3. You need to make sure that you distribute that X in there.
foiling is kind of like the distributive property for like two groups of things. Now, why did you just tell us foil, Mr. Daldy? Like foiling is way easier than this concept of making sure everyone meets everyone, right? Yeah? Do you guys agree or not? I mean, it's about the same. All right. Foiling is like the quick dirty version, but there could be if I it's a great way to introduce it to you because you can kind of get it and you can kind of hang with what I'm saying. But it's also and foiling is good, but here's the problem is later on one day in algebra 2, which actually we're in algebra 2, so later on one day we're probably going to end up with something like
X plus 3 times
x squared plus 4x
plus 5 or something like that.
and there is no foil for that. You know what I mean? There's no idea of foil because there's like this one right here doesn't have a first and a last. It has a first and a middle and a last. You get it? So if we're going to expand upon this concept, I'm going to have to go back and say, well, remember that idea of meeting everybody? Let's go back to that, and then this becomes easy. You see what I mean? But we're not doing something like
This one, also don't worry about it. Don't freak out.
We're going to do this one. I'll do one problem for you just so that I can, now that we've all got foil, let's do it. All right. So 4z, -1, z, and -4. By the way,
I hate minus signs. I love negatives.
I hate minus signs. This is a minus sign.
I want to turn it into a negative by doing this.
Plus negative. The negative goes along with that -1. Same deal here. Plus negative. We cool with what I did so far? By the way, I'm going to burn through this because this is like 2 weeks ago lecture. You guys should have this by now. Can you guys see it? Alright. Alright. So what I'm going to do is first outer inner last.
Foil.
And the only reason why I'm going through this is because when I was looking through your homework, I was like, a good, maybe about 4 or 5 of you didn't understand what you were doing. And actually, I think a few of you even like did understand what you're doing, but you burned yourself on the negatives. Like these small negative things, like killed you on that. So that's why I'm going through this. So when you go through your homework, if you got like a 8 or a 7 out of 10, then and I give you notes on like, hey, you did this one wrong. Hey, this idea was wrong. Go through it and then see what your mistake was. Redo the problem for me. All right? All right. So when we're foiling, we want the first times the first, so that's
4z times z. By the way, I hate to do this, but I mean, I kind of do this for
whoever hangs out with me, which makes you guys think, well, why should I hang out with him? Hey, what's up, Brandy? Come on over here. Brandy. We're back here. Yeah, sure. No, don't worry about it. All right, here, pull up a chair. For your sake, we moved because we didn't want to have to cram 4 people inside of that room, plus me. Because I take up like 2 spaces. All right, anyway. By the way, just to give you a heads up. Okay, wait.
This is a 4. Gosh, that's an ugly thing. Let me do it again. All right, that's a 4z
times
z.
And by the way, just to give you a heads up, I make my times symbol like that, or actually I put parentheses around it. I never use the X looking thing as a time symbol. I'm going to point out Mitchell's mistake yesterday. He was dealing with a whole bunch of X's, and then he put in a time symbol, and then he had like an extra X in there. And he was like, what's going on? And I was like, well, you mixed up your time symbol and your X together. So I'm just letting you know that's why we do it. I don't do it just because I'm a stickler and I make you guys, I'm a jerk. Well, I kind of am, but I mean, I do this mainly because I'm trying to make sure you guys are careful. Anyway, this is the first. Now we got the outers, so that would be -4 times 4z, which is plus -4 parentheses 4z, and we know that as -16z, but let's move on. Now we got the inners, which is -1 times z, which I'm just going to put that as -z. Is that all right? And then we got the last, which is -1 times -4, which we know as rhymes with door. 4, good, awesome. So simplifying this, I get 4z squared minus 16z plus -z plus 4. I'm looking at 4z squared minus 17z plus 4. Are we cool? Did I do that right? I think I did. Yuppers, we good? Awesome. Awesome. All right. Let's ditch this. We'll move on to quad 2,
and I'll talk about the homework that was due yesterday because I think that some of you guys are like, wait a second, I'm having trouble with this. And then after that, we're done with
review. We'll go move on to finishing off the rest of chapter 3. And then we're done with class for today. I'd like to finish early because, to be honest with you, I didn't prep the next class that I have to teach. And it starts at 11 o'clock when I finish with you guys. So if I can finish about half an hour early, that'd be good for me so I can have time to put together that PowerPoint. All right. Which you guys are like, sweet, I want to finish early. All right, let's see.
I think some of you were telling me that, like,
this was a little weird for you. Right? This concept of... Oh, here we go. So this one's not bad, right? Like, if I ask you to graph, what is x squared minus 6? You know, that's just parabola drop down 6. Cool? And I think that we didn't really highlight this idea, and I noticed that it popped up here. I should have really kind of talked about this more. Remember when I said, all right, wait, okay, let's do this. What is this going to do? What is that going to do to the parabola? We got the 1/4 x squared minus 3. All right, it's going to make it wider. It's a fattening kind of deal, right? We got the cheeseburger plan. And it moves it down 3. All right, so it just basically opens it up, moves it down 3. We cool? But one way, instead of saying makes it wider, like pulling it out this way, because what we did was we talked about how it makes it wider or makes it or it makes it narrower, right? It's the skinny plan versus the cheeseburger plan. Cool? I think that maybe a better concept for to introduce to you guys is, you know, when it makes it wider. I guess one way you can kind of think of it is it makes it like it takes it vertically and presses it down. Kind of like if I had like a Play-Doh, a person made out of Play-Doh. Okay, imagine I've got a little person made out of Play-Doh. It looks like this. Okay, and I like push him down like this. I start compressing it this way. What's going to happen to him? He's going to get fat, right? As opposed to I have a little Play-Doh man and I take him by the head, or let's say a gummy bear. Gummy bear works because you guys do this with gummy bears. I know you do. I do it all the time. Really, you don't be like, don't
Like
kill
gummy
me,
bears?
please. Don't you guys do that with gummy bears?
No, I just eat.
Do you kids eat gummy bears now, or is that like a thing of the past? Is that not cool? All right, fine. I'm just making sure. I don't know these things. All right, so let's say that we have gummy bears, and you take this gummy bear, and you grab it by the head, and grab it by the foot, and you like, ah! What's gonna happen to the gummy bear? It's gonna get skinnier. So I'm gonna switch over to that concept. When I have something like this, the 2x squared, I'm gonna say that I'm stretching the parabola, which essentially means that I'm also making it skinnier. Okay? And the concept that I have here is when I have a quarter over here, I'm going to say that I'm taking the gummy bear and I'm going like this. Ugh! And then it's kind of like, you know, like smushes down and gets fat. So essentially that's making the parabola wider, but I'm actually really compressing it. We cool with this? So like when I say that, oh, okay, I'm going to do the reverse. Instead of giving you the equation, asking you what the graph is, I'm going to tell you what the equation did, and I want you to tell me what the equation is. So if I compress it by a factor of 2, what did I do?
Well, that's x squared what?
Compressed. What is that?
I got messed up on this because of the wording.
Yeah, exactly. Should I put a 2 in front? Is that compressing it? You should put a half in front. Because a half compresses it or makes it wider. You guys get it? Yeah, I know. See, Mitchell was kind of getting messed up because he was saying, wait, compressing it makes it narrower. No. I'm talking about compressing it vertically. Which, we're talking about vertical here. We're compressing it vertically, which in essence, it stretches it horizontally, I guess, if you want to say that. But I guess, just think of it as compressing a gummy bear down. You're going to get a fatter gummy bear. Right? Whereas if you stretch a gummy bear up, you're going to get a skinnier gummy bear.
By the way,
We compress it by a factor of 2, shift it down 4, so that would just be tack on a -4 at the end. That's your answer for that one. Are we cool? Alright, let's stretch this thing by a factor of 2. So what do I do now? Do I put a half out in front? Put a -2?
why -2?
Because they told me to reflect that sucker. So reflected 2, shifted up 3. You slap on a +3, and you just like, boom, done with homework number that was due on like Thursday or like Monday or something like that. Cool? Alright. Now, I need to talk to you guys about this concept, and we talked about range, right? Like, let's look at this one. This one is 1/2
X squared -4, so that would be something like this. Down 4.
and a fatter parabola. Or maybe a compressed parabola. We should say that, right? What's the range of this parabola? What are the possible y values this parabola can give? By the way, it goes up infinitely vertically this way. But what is the possible y values you can have? Or I got a better question. What are the impossible y values you can have? Do you understand the question? -5. Exactly. How is this graph going to give me a -5 when the lowest point it goes down to is -4? You see what I mean? What about a -4.1? Can I have that? No. What about a -10? Nope. Because it goes down to -4 and that's it. It bottoms off. Then starts going back up. There's no way it can get to -5, -10, -4.000001. Even that it can't get to. We cool? So when I tell you the range of a parabola, like look at this. The range of this parabola is, the parabola is allowed to be bigger than +4. That tells me this parabola looks like this. You see it? Because it's telling me the range of this thing is, it has to be bigger than 4. Okay, well, if I want to graph that, that would be x squared plus 4. That's it. That's all that's telling you. So were you guys confused with this particular homework? Like this page? All right. Does that make sense now? Like if I tell you the range, essentially I'm telling you how this thing is moved up and down. I'm also telling you whether or not this is positive or negative. Right? Because if I said y is smaller than or equal to 4,
That would be a parabola that looks like that. That tells me, hey,
you got an reflected parabola and it's moved up 4. You see what I mean? Randy, you're going like this, which means you're concentrating. All right, okay, just making sure. I'm just checking. Any questions? Because this is me coming back to this idea. But then you have to use y in the equations. Technically, Ted, what we're talking about instead of y is we use h of x or k of x or j of x or m of x. This means, remember how I always use f of x? This means the function whose name is f as it depends on the variable x. That's what I'm literally saying right here. In those 2 letters that I wrote down, not even a word, just 2 letters, I've said the sentence, this is the function f as it depends, or this is the function f named f as it depends on x. What is h of x? This is the function h, it's called h, as it depends on the variable x. And usually, we can interchange y with that. Does that make sense? Because y would be like the vertical, where the thing ends up vertically. We cool? And yes, Thomas, I probably should have used that terminology. I was teaching you on how I think about it, but not necessarily how this text thinks about it. Thomas is saying the thing that really messed him up is he's saying compressed means wider and stretch means narrower. Yes. When you compress a gummy bear, it gets wider. When you stretch a gummy bear, it gets narrower. Good? All right, cool. So, let's see. To recap the whole story. Excuse me. To recap the whole story. In Quad 1, all I taught you was basically how to multiply quadratic equations together, or how to multiply 2 polynomials together and make a quadratic equation, right? And I introduced you to this concept of quadratic equations. In this chapter, chapter 2, all we did was talk about like moving a parabola up and down, making it skinny, or not making it skinny, stretching it vertically, compressing it vertically, or flipping it up and down, right? In chapter 3, all we did is take that same parabola and move it right and left. That's it. And the thing that we found, and so now what I'm doing is
I'm just saying, okay, let me start off and finish off
chapter 3's lecture. And chapter 3 I'm going to break up into two parts. It's because I finished the first half last week. Or was it? Yeah, I finished the first half on Friday last week. So hopefully you guys attended lecture. But if you didn't attend lecture, let me just kind of recap it for you. Cool? Basically, all we're doing is focusing on... We talked about moving the parabola up and down. And now we're talking about moving the parabola right and left. And that's it. So really, what we found is if you have something like f of x, which is also known as y, is equal to x minus 3 squared, that moved it 3 to the right or left. Which way do you think it would have moved? X minus 3. Does it move left or right? You would think that it moves left, right? And you would be absolutely wrong. This is the funky thing about it. When you're talking about moving it up and down, it's totally intuitive. When you're talking about it opening up or opening upside down, totally intuitive. When you're talking about moving it right and left, that's counterintuitive. If I say x minus 3, what it will actually do is move it to the right 3. It will move it 3 to the positive direction. And by the way, I'm talking about x minus 3 squared. Well, what I'm saying is the minus 3 is inside of the parentheses. Because if I had a minus 3 outside the parentheses, what would that do? That would just move it down 3. But if I take the minus 3 and put it inside the parentheses, that would move it to the right 3. And that's it. That's the whole thing we covered last week Friday. We cool? So, Mr. Dalton, why did you take so long to cover chapter 3 if that's it? Well, because here's the thing. I could just tell you what the answer is. I could let's take Ted's example. Ted wrote down. Oh, okay. I see what Ted wants to do. Okay, let's take Ted's. Let's kind of take a version of Ted's example. F of x is equal to x plus 4 squared. What would that do, folks? F of x equals x plus 4 squared. It would just take it to the left, what? 4 spaces, that's it. We cool? And the reason why I went through this so slowly on Friday is because I hate pulling equations out of my butt and saying, remember that. Remember that when it's inside the thing, it's counterintuitive. I'd rather you go through the stress of experiencing it yourself, and then you folks like, oh, I get it. Like you make up your own rules about it. So that's what we went through. Now, Ted's doing something a little bit funky. Ted is talking about, and I'm going to put the pause button on your brains and just say, look, this is something aside. I'm going to talk to Ted about something, but you guys can watch because I think it's important as well. Ted's talking about, well, what's one last thing we can do to parabolas? We know how to make it wider. We know how to make it skinnier. We know how to move it right and left. We know how to move it up and down. We know how to flip it upside down. What is Ted talking about? He's talking about, well, what if we take a parabola and move it like this? Does that make sense? What if we turn it 90 degrees? Can we do that? And my answer is yes, absolutely. But then your parabola would look something like this. And Ted wrote down this. Okay? What's the difference? It's a y instead of an x. All we did was we replaced the x and the y. We interchanged them. And when we interchange the x and y axis, it's basically like turning our head 90 degrees like this. So you take the regular parabola and you just turn your head. Oh, good, it's a sideways parabola. The one thing, Ted, that you messed up on, though, is you put f of x is equal to y plus 4 squared. But this function is a function of what variable? Is it a function of x? Does this function depend on x? No, Diamond's got it. Since this function depends on y now, you should have written f of y is equal to y plus 4 squared. What happened to my computer? Okay. I don't understand. Alright. Does that make sense, Ted? We cool? Alright. What does the computer screen look like for you guys? Because my computer screen's a little bit funky. Can I move on? Can I move on to like the topic we're supposed to start today? Can you see this? Alright, as long as you can see this, don't worry about the black box. I have no idea what those are. There, I'm trying to get rid of all of them. Apparently I gotta put my mouse over it. Seems like a stupid game, but whatever. Alright. The last thing we covered, before we left was we talked about solving the equation, solving the quadratic equation. So we talked about moving it up and down. Oh, no, that's right. The last thing we covered in quad 2 was we talked about solving the equation, right? When I solve a parabola, what is it that I'm actually looking for? I taught you guys this yesterday. When I solve a parabola, what I'm looking for is when does the dang thing cross the 0? Does that make sense? When are we talking about it crossing 0? When does it cross the x-axis? We don't need to, and the way we did that was we graphed it, and then we looked at the graph and we said, oh, here and here, right? And then I had you check it. You guys remember? Bless your face, by the way, Brandy. That's what they said. They said, bless your face. I don't understand what so bless is. YouTube?
Totally understand, yeah.
Bless your face? Alright.
Bless your face. I'm not even gonna.
Alright, that's cool. Okay. Yeah. Quickly, do it. Do it quickly. Alright, fine. I'm just out of the loop. I'm sorry. Okay? I'm not totes cray all over YouTube like that. Yo. Yeah, that was good, right? Yeah, that was pretty good. Yeah, alright, fine. Alright. One way we could solve a parabola is we could graph it, and then after we graphed it, we could solve for it, right? Like, for example, let's try this one. 2x squared equals 32. 2x squared equals 32. What I could do is I could divide both sides by 2. Write this down, by the way. It's kind of interesting. And I have x squared equals 16. And then I could take the 16 onto the other side. How would I do that? I subtract 16 from both sides. So I have x squared minus 16 equals 0. If I were to graph x squared minus 16, what would that look like? It would be a parabola 16 points down. And guess what? It'd be over here. In fact, let's move over to Deskpost and see if we can get this thing graphed for us. Please don't make me regret clicking on the internet, because it's laggy. There we go. I like my picture that I have when I put up that video, because it's always the first thing you see when you do this is like this. I feel like I'm a rapper, like I'm like... Anyway, whatever. Graphing calculator. By the way, I use a graphing calculator. You can use a graphing calculator. I'll show you where it is. It's right over here. I just type in graphing. I don't even remember the name of the address. I just type in graphing calculator. And Desmos seems to be a pretty cool graphing calculator. Alright, let's graph this though. So it's x squared minus 16. Alright. Bless your face. I got it. All right. Where does it cross? Where does this thing cross? Positive 4 and negative 4. We cool? That could be one way you could solve this problem. I solved the problem. I figured out where it goes to 0 by graphing it and figuring out where it crosses. Cool? There's an easier way. Why don't we just do this? Divide both sides by 2.
I have x squared equals 16.
What squared gives you 16? Or maybe I'll do this. I want to get x all by itself, right? What's stopping the x from being all by itself? It's the fact that it's squared. What is the reverse of squaring something? Do you know? It's this symbol right here.
You seen that? It's a square root.
Well, when you square root one side, you better square root both sides. Okay? And you have x equals the square root of 16. What is the square root of 16? 4. Is everyone cool with that? You guys good? You guys understand that? You like that? Because you're all half wrong. Just letting you know. I love when I trick you guys. Because it makes you remember, hey, Mr. Daldy tricked us on that punk, and now I remember it. Alright. I call myself a jerk and a punk all the time. But anyway, let me finish. What? I already wrote it down. Alright, let me finish. In fact, you might want to write this down. Whenever you square root both sides, you need to add a plus minus. Why is that? And what I'm suggesting to you is you need to, since I square rooted both sides, you need to add in a plus minus 4. Do you understand why, or do you want me to explain why? Alright. We can all agree that 4 times 4, positive 4 times positive 4 is 16, right? But I'm suggesting to you that negative 4 times negative 4 is also 16. Yes? Yeah? So what I'm saying is, you guys need to account for both this crossing over here and this cross over here. It crosses at both positive 4 and negative 4. That's why you need the positive and negative in there. Because you are accounting for both the positive 4 and the negative 4. This right here is actually 2 answers. I could write it, in fact, I probably better write it, since I'm just introducing it to you, as x equals positive 4 and x equals negative 4. To shorthand write that, I just put plus and minus 4. Those are actually 2 separate numbers that I'm saying. The answer is both positive 4 and negative 4. We cool? Did you guys know that, by the way? I mean, have you guys ever taken the square root of both sides of something? You've done that before, but did you know to add the plus or minus? You did? You just let them all get it wrong when you said, oh yeah, I agree, positive 4, that's the only answer. Alright, anyway. Let's do this one. Divide by 2,
Divide by 2, and I get x squared equals what?
rhymes with sine, vine.
9. 9, that's a good one. Alright. So x is equal to what? What is x
Straight up equal to. X is equal to 3.
I disagree with
Almost all of you guys are answers. There we go, Diamond. It's positive.
and negative 3.
Because positive 3 squared is 9. Negative 3 squared is also 9. We cool? Alright, let's skip number 3 because
That's kind of boring already. I'm tired of these things. What about moving on to number 4?
what do we do here? I want to get x all by itself. I need to get rid of that square on the outside. How do I do that? Why don't I square root everything? Sound good? Because we were talking about x minus 1 squared, and I want to get rid of that square. Why don't I just put the square root around x minus 1? The group called x minus 1. We cool? So this would be x minus 1
equals what? What's the square root of 4?
Plus and minus 2. No, not details. It makes a difference. Alright. Plus minus 2. Hey, Thomas, that's pretty cool. How'd you get the plus minus symbol? Oh. Option shift plus keys. Or plus key. That's cool. Alright. So, now what I have to do
Is I need to get x all by itself. How do I do that?
X is not all by itself.
How do I get x all by itself?
No, I already
Squared it. I'm at this point right here.
What is stopping x from being... Exactly. I have a minus 1 on it. I just gotta add 1. There's a minus 1. I gotta add 1 to get it all by itself. So I put plus 1.
But keep in mind that these are two different answers. So this would be... I'm going to plus 1 on this side. I'm going to get rid of this thing over here. I have x equals positive 2 plus 1, which is what? What's 2 plus 1?
3. And x is equal to negative 2 plus 1. What is negative 2 plus 1? Negative 1. These are my two answers that I give it. Does that make sense? So when I square root both sides, that's when I throw in the plus or minus, and then I can just use regular algebra, but I need to remember that those are two separate numbers. Here, I'll prove this to you, and I think it would be kind of cool. Let's try this. X minus 1, oops, x minus 1, look, I'm basically graphing the equation I just showed you.
This is the graph. That is the graph for this equation right here. We cool?
Look at the graph.
Where does it cross? At negative 1 and 3 and negative
1. Booyah! What's up? Yeah, alright, fine. Check this out. Mitchell is saying, but Mr. Dalday, you just taught us how to cheat on our homework. Like, instead of doing this, I can just graph it and then the computer will tell me the answer. I'm like, yes, I did. I know, I showed you. But guess what? This is why I ask you to show me your work. Because if you just show me, like, the answer, then I know that you probably didn't do the work. And I'd be like, no credit. That's right, suckers. You like that? No. I'm just saying. Okay? Like, I don't mind you checking your answers. That would be fine. But I need you to show me the work. Cool? Alright. Let's try...
Which one looks hard? This one looks hard.
3x minus x plus 2 squared. Ooh, this one looks real hard.
Alright, we'll do 7 and 8. Alright.
Pull out a pencil and paper. Write this down. Come on, you guys take notes. 3x plus 2 squared equals 75. What do I do first? You guys have any ideas? Should we square root both sides? Bernice is... I think it's Bernice. Bernice, are you saying... Alright. Thomas is saying we should take care of that exponent first. What I'm suggesting is this. Let's get rid of that 3. And Diamond is saying we should distribute that 3 inside there. Like that. And I say definitely don't do that. The reason being, and that's actually a good suggestion, but the reason being is because there's a square here. If that square weren't there, then I would say you can distribute that in. But since that square is there, that thing is kind of like its own entity, and you can't like mess with it. You can't put something in there. So what I'm suggesting is, why don't we divide the 3? Why don't we put everything on one side first? So we have the divide 3 by both sides. I have x plus 2 squared equals 75 divided by 3. 75. If you have 75 cents and you divide it into 3 equal parts, how much money do you? 25. There we go. Come on, you guys. You get a quarter. All right. By the way, Diamond, I also kind of made, like, I also kind of knew what was coming up. And that's just from doing, like, a bunch of these problems. I knew through experience. And so you guys are saying, well, wait, Mr. Dalton, we have no experience with this. How are you going to expect us to know what's coming up? The reason why what I'm saying is I know what's coming up is because I know that I'm going to have to square root both sides, right? And so when I know I have to square root both sides, I'm looking for a number that's nicely square rooted, like 25. 25 is a nice number to square root. So I'm thinking to myself, how can I make 75? What can I do with the 75 and the 3 to make it 25? That's what I'm thinking in my head. But anyway, what should I do now? Square root both sides. When I square root both sides, I throw in a plus or minus. So I have x plus 2 equals plus or minus, what is the square root of 25? 5. Both positive 5 and negative 5. We cool? At this point, I would actually break it into 2 problems. I would break it into x plus 2 equals 5 and x plus 2 equals negative 5. Can you see that? We good? What is x, or how do I get x all by itself? Minus 2, so x is equal to what? Five minus 2. 3. Good. All right, just making sure. I also minus 2 from this side, and I got negative 5 minus 2, which is negative 8. Negative 5 minus 2. Negative 7. There we go. But you know what, Mitchell? I give you a hard time, but you know what? You're a rock star. Because the fact of the matter is you answered. Even if you got the wrong answer, and I'm going to, give you a hard time for getting the wrong answer, you still answered. That's better than everybody else who didn't answer. Even if you got it wrong. Just throw it out there, dude. You know? Yeah. Ted's like, I thought he was an all-star. Yeah, he is an all-star. All right.
So x is equal to 3 and
Negative 7. Are we cool? Would you guys like to know how to cheat? I'll show you. Ready? I'm going to take this equation.
I'm going to put the 75 on the other side. So I have 3x plus 2 squared minus 75 equals 0. I'm going to graph this thing. And I'm going to see when it
Equals to 0. So I put a 3 out here, and it's an x minus 2. No, x plus 2. Minus 75. Whoa. There's my graph. When does it cross? At 3 and negative 7. But instead of having to graph it, I got those answers. 3 and negative 7. No graph. Booyah. What's up? That kind of stuff. Yeah. Alright. Are we cool with this? Do you guys need me to do any more of these? I apologize. I think that this homework is probably going to take a little bit longer than I thought it would. Let's see. That would be a fun game to play. You guys should probably do this game. Print out page 13 and 14 and cut them up. I think it is. I think it's good. But I'm not going to make you do it. Let me just look up what's coming up, so I know what to cover for your stuff. Because all of this stuff is your homework. You just have homework for the rest of the thing? Yeah, it looks like it. Alright. Okay, let's move on. You ready? I'll tell you what. See these blue problems that are circled in blue? They're your homework. But, why don't I do one of them for you? Sound good? So, now you guys are like, I guess it's worth coming to class. Because he's doing his our homework for us. Alright. You know how we talked about
x-intercepts and y-intercepts?
Right? And for parabolas, they can have 2 x-intercepts. They could have 1 x-intercept. They can have no x-intercepts. But they're allowed to have up to 2. Yeah? For parabolas, they should only have 1 y-intercept. Unless they're sideways, but we're not talking about that. Oh, Ted's asking, if I do one of your homework problems for you, can you cut it off? Can I cut it off the required stuff that you turn in? My answer is no. I'm thinking about it like, well, if I do it for you, why don't you just write it down while I'm doing it for you right now? And then boom, that homework problem's done. Because then I would have to go in and change all of these things. I'm doing it for you anyway. Why don't you just, you know. And the thing is, here's my motivation for making people watch the archive. Is if people try to get through this class without watching the archive and or whatever, then what they'll do is like, hey, if you watch the archive, or better yet, if you attend class, Mr. Dalday cuts your homework down for you and actually does some of it. Whereas if you don't attend class, then you got to do it all yourself. All right. Remember how we were talking about the x-intercepts and the y-intercept.
Cool? There's like these 3 points that are kind of points of interest for us.
Yeah? What can you definitely
Tell me about the x-intercept.
Is there something you can definitely tell me? At the x-intercept.
What is a point that you definitely know?
Ah, I love it.
I know that wherever these x-intercepts are, if there is one, that is, because there's a possibility that
There isn't one. You can
have a parabola that looks like this, and then it never crosses the x-axis.
But I know that at the x-intercept, y is equal to 0. You agree? Conversely, at the y-intercept...
Wait, what's up? Is it in Save Me? Because you don't like being here?
Okay, all right, fine. Conversely, at the y-intercept, what can you tell me about the x value? At the y-intercept, at this point right here. Not y is equal to 0, because y-intercept is an actual value. It doesn't need to be 0, it can be something else. But what is definitely thing you know about the x? X is 0. So in this case, x is 0, and in this case, y is 0. We cool? So if you want to find the y-intercept of something, it's very nice and straightforward. All you do is make what? You take your function, and you make it what? If I want to find the y-intercept of this, then what I should do, not turn it sideways, but what I should do is I know that for the y-intercept, I know one fact. X is 0. So I should take this,
and if I want to find the y-intercept, I'll take this function, I'll plug in x equals 0 there.
Does that make sense? And that will help me find the y-intercept. So then I have f of x equals 5 times 0 plus 2, which is 2 squared. So that would be 5 times 4, which is 20.
Y-intercept is 20.
Done. You like it? Does that make sense? Now, the x-intercept's a little bit more tricky, but you guys already know how to do this, I think.
Do it like this.
If I have 5
X plus 2 squared. Oh, no. Here, 5x plus 2 squared. So I have f of x
equals 5 times x plus 2 squared. And I'm looking for the x-intercept, then I set y equal to 0.
Do you see a y anywhere here?
This is a y. Remember I said f of x is the same as y? So you just set that equal to 0.
0 is equal to 5 times x plus 2
squared. What do I do first? Let's get rid of that 5. Divide him. What's 0 divided by 5?
0 equals
X plus 2
squared.
What do I have to do with this thing? I square root it. Okay, fine. So,
Plus or minus?
what's the square root of 0? 0 equals x plus 2. Okay? And then,
You just subtract both sides.
and you have,
X equals negative 2.
by the way, why can I just disregard the plus and minus when it's 0? Because plus 0 and negative 0 is the same as just 0, 0. Got it? Then that's the only number that does that. So x is equal to negative 2. Are we cool? Negative 2. The x-intercept. How many x-intercepts are there on this graph? Are there 2 of them? There's only 1 of them. What does that tell you? Think about it. The parabola is going to come down. Is it going to cross twice? No, because if it crosses twice, then there would have been 2 x-intercepts. Does that make sense? I'm going to get to your question in a second, Ted. But what I'm saying is if it crosses twice, then there would be 2 x-intercepts. It only crossed once. So that tells me that this parabola probably looks something like this. At negative 2, it crosses once like this. What happened again? Alright, there we go. Does this make sense? Are you sure? Because you're going to have to go home and do this by yourself. And, like, it's easy for you to say, oh, I get it. Yeah, I get it. But I want to make sure. I'm going to stop you and make sure that this stuff kind of makes sense to you. We cool? Would you guys like to see, like, how it all kind of comes together? Watch this. Think about this. 5x plus 2 squared. So you're telling me to graph this thing. If you were to look at 5x plus 2, what does the plus 2 do again? What does this plus 2 in here do to the parabola? It moves it which way? To the left. It moves it to the left 2 units. What does the 5 do? What does that 5 do? It stretches it vertically. It makes it a skinny one. Exactly. Very good, Diamond. Very good, Mitchell. So, I mean, like, you can see the graph in your head already. Well, here. You can see the graph right here. It's moved over 2, and it's made skinny, or it's stretched vertically, right? What is the x-intercept? Negative 2. Like we just said. What is the y-intercept? Positive 20. That's where it crosses the y-axis. So without even graphing this, you can figure out what these numbers are. Does this seem kind of cool to you or not really? Like, I'm just like, I'm over this. We good?
So cool, Mr. Dog.
Oh yeah, it's so cool, Mr. Dudley. I'm so excited to learn math from you. All right, let's see. Let's do this one together because I think that you guys can easily do this one. I think one of your homework sets is this page, which is page 12, 11, and 12, I think. And I think it's problems 9 through 15. And then another homework of yours is page 15 and 16. Let's check. Let's double check this. I have, for chapter 3, I have, yeah, warm up. Page 11 and 12 is homework. And then page 15 and 16 is homework as well. We cool? But why don't I do 2 problems from your homework for page 15 and 16. So make sure you write this down. Look at that graph. We'll do it together. Ready? Look at this graph. Tell me what it is symbolically. Tell me the equation for this graph. You're just straight up looking at the graph. Boom, tell me the equation. Okay, identify where's the vertex. It's right here. It's a -1. So how would I move a parabola to the left 1? Would it be x squared minus 1? It would be x squared plus 1? Yes? No, it's not. It would be plus 1, I agree with you. But if you look at what I wrote down, x squared plus 1, isn't that a regular parabola just moved up 1? I want to move it to the left 1. So where, there we go, Bernice has got it. I would put it x plus 1. That plus 1 would go inside of the parentheses. When it's outside of the parentheses, you're moving it up and down. When it's inside the parentheses, you're moving it left, right. We cool? Yeah, that's it. That was that homework problem right there. You guys are like, wait, what? My homework's actually kind of easy. Yeah, your homework's not that bad. Let's do this one. This one looks hard. And it's not a circled one, so, I mean, yeah, I guess it's not one of your homework problems, but whatever. Graph each of the function. Be sure to indicate the vertex and the intercept. Okay. So, tell me, what is this graph? Tell me what the -4 does. It moves it to the right 4 spaces. Awesome. So I've got my regular parabola, but it moves to the right 4 spaces. So it's right here. What does the 1/2 do? So here's your normal parabola, and it compresses it or makes it wider, so your actual graph will probably look something like this. Now, when you do your homework, am I going to make you make a table and burn you because your shape was a little bit too wide or not wide enough or whatever? No, I don't care. I just want to make sure you guys understand like the basic graph, what it should look like. All right, what else did it tell us to indicate? The vertex and the y-intercept. Okay. The vertex for this thing right here is this point right there. Got it? So it's actually +4,
Comma, what?
comma, negative what? Comma, well, I agree with
Diamond. It's -0, or also known as
0.
it's not negative at all.
4, comma 0. We cool? That's the vertex. That's the point at which it touches. I mean, the vertex of this graph happens to also be the x-intercept, but the vertex over here is the lowest point on the thing. We cool? What is the y-intercept?
All you do is plug in 0 in for x, and you have 1 half times -4 squared, which is 1 half times 16, which is 8.
So apparently it crosses at 8, right there. So that kind of helps me with the shape of my parabola. Now, I don't mean to pick on anybody. I just want to make sure. Adriana, often or sometimes you've written to me like you don't understand. Do you understand what we have here? Also, Diamond, I think that you wrote down that you had some confusion. I'm just making sure I want to go slow enough so that everyone catches it. We good, twins? Mitchell? Brandy? All right. I'm going to do this one. So, I'll tell you what, I told you I would do 2 homework problems. I'll let you choose the second homework problem.
Whichever one's the hardest.
Which one do you want?
I think it's the hardest.
Yeah, just choose the hardest part.
Well, let me do 2 more. I'm going to do one more that's not your homework, which is like, I'm making you do 3 and 5. I'm going to do 4 for you, so that way you know, hey, this is just like what I'm used to. And then I'll do one of your homework problems, the hardest one if you want. Okay, let's do it. Oh, this is all still graphing? Graphing's so easy, I feel like. Alright, whatever. Let's do it. Let's graph it. So we want to do the same thing. Number 4. Okay, let's do it. What does the +2 do? Moves it to the left 2 spaces, so it's right here. What does the -2 do? This -2 out in front. Inverts it, stretches it. So we're looking at a problem that looks kind of like this. A little bit skinnier. Yeah? Where does it cross? Where does it cross the y-axis?
Well, how do I find that?
The y-intercept, to find the y-intercept, I can simply
Do what?
plug in what? You're on the right track.
0 for x.
I plug in 0 for x.
So for y-intercept, x equals 0, or for this problem, -2 times 0 plus 2, which is 2, squared. So that would be -2 times 4, which is -8.
Apparently that's where it crosses. So this is what my parabola would kind of look like. Something like that. Are we cool? And there, I graphed it. I told you the y-intercept. Actually, the y-intercept
Is -8, and so you guys should write that down, and then also the vertex.
give me the coordinates of that vertex right there. Where does it come to a point?
0.
At -4.
4, comma 0.
Exactly. What is that?
You put it at -2.
No, actually, it's not -4,
It's -2, 0.
You got it wrong. I just kind of like, yeah, -4.
Tables.
Yeah, that's right.
No, I just.
Really? You had the forethought to kind of like, you're like, I'm going to trick the teacher and give him the wrong answer. Yeah. I'm a punk like that. Let's see. What do you want me to do? Which homework problem do you want me to do? Do you want me
What do
to...
you think is the hardest?
I don't know. I don't know which one's the hardest. Which one? They're all kind of easy to me. Like, not to be a jerk about it, but I mean, they're all not that bad. So I'll let you choose. Which one do you think is the
I
hardest?
think it's the most complex.
Which has the most steps? Steps are annoying.
Yeah.
Which one has the most steps? Go to that one.
I don't know. They all have one step. They all just basically say graph this.
What is the big step?
All right, this one looks good. Number 4. Number 4 of page 16. So you guys are realizing, I should probably attend class nowadays because Mr. Dalday actually does my homework in class. All right, whatever. Let's do it. Ready? You know this thing's gonna have an X squared, right? All right. Well, here. Tell me how this parabola that you're seeing is different from a regular parabola. It's inverted, so we know we're gonna have to have a negative in there. Got it? What else? It's shifted to the right 4, so it's gonna have a plus.
No, a minus 4 in there somewhere. Okay.
What else? It's a little wider. How can you tell? Well, a good way to check is if this were a parabola right here and it's inverted, a regular parabola would go out to 1, 1 over here. And then it would do something like this. So that's the way the regular parabola would look. This one looks a little bit fatter to me. Do you guys agree? So, what's the equation? Negative 1/2 times. That's perfect. That's exactly the answer. Boom. Which Mitchell is now wondering, why didn't I turn in all of my homework? Because, like, I obviously get it. And it's actually not even that bad. You know what the struggle is? And this is what I called. I called your mom and I told him. I told your mom and dad, actually. I think I was talking to your dad. I was like, I hate to say this, Mr. McAngus, but smart, but lazy.
Oh, that one. Oh, yeah.
Actually, you know what? I think I might need to call your mom because you haven't been turning in your homework. All right. I've actually been pretty good about calling your parents about like that kind of stuff. All right, so we good? You guys feel like you guys can graph? Now you can pretty much graph any parabola under the sun, right? You know how to move it up. You know how to move it down. You know how to flip it. You know how to skinny it, fatten it. Well, stretch it vertically, compress it vertically. You also need to know how to move it right and left. There's like no parabola out there that I can throw at you that will mess with you. Because that's all the parabolas. I mean, beyond that, what else can you do to a parabola? Besides maybe turn it right and left, but we're not even going to cover that in this class. Okay, all right. That would be kind of tough. Turning it like not just 90 degrees, but turning it 45 degrees. You know what the answer is? I don't even know how to do it. I don't know how to do that parabola. Actually, I do, but I don't know how to do it with high school math. I know how to do it with like college math. So obviously, that's not something we're going to do in this class. Well, why don't you do your regular homework first, and then you can do the extra hard stuff. Does anyone have any questions about the homework that we've done, the homework that you guys did? If not, I'm going to finish class. And I'm sorry I didn't give you your break in class today, but you guys could hang with it in an hour and a half. Actually, we didn't even got an hour and a half. We just went just a little bit past an hour. You guys good? All right. I feel like I covered a few tough topics today. On Friday, we're going to start up chapter 4 already. And I think we only get to chapter 7. So we're kicking it along. We're going to hit chapter 4 on Friday. We're going to start it and then we're going to finish it on Wednesday next week. Then we're going to start chapter 5 next week Friday. Finish it. Chapter 6 we're going to do in 1 week. And then Chapter 7 is going to take 2 weeks long. And Chapter 7 is going to be like I think it's one of the coolest of the chapters. Because you're doing things, because basically all we're doing from this point on is we're not going to even move on to a different shape. Everything from all the way up to Chapter 7, we're still dealing with parabolas and quadratics. It's just now I'm going to show you how to, you know how like today I showed you how to add in how to solve for it without graphing it. Today I showed you how to solve for it and you had to throw in the idea of the plus and minus. Eventually what I'm going to do is I'm going to show you how to solve in chapter 7. What we're going to do at the end of this thing for the last 2 weeks of class, I'm going to show you how to solve parabolas that are more advanced, that cross at weird places. You know, like not every parabola crosses nicely on 2 and 6 and negative parabola. You know, parabolas usually cross just randomly anywhere. You know what I mean? And I'll show you how to figure out exactly where they cross that way. We cool? And so far, all I've been doing is I've been giving you parabolas that are nice to graph. Well, there's parabolas out there that are very not nice to graph. Well, that's what we'll cover. So all we're going to do for the rest of this quarter is... Oh, that's right, sucker. You know what? Brandy said if it's not nice to graph, then they don't deserve to be graphed. And I would argue this. But when you're doing an experiment and it has to do with actual numbers, usually things aren't nice to graph. Usually, like, I'm going to do this experiment. Hey, guess what? It just so happens to fall exactly on 2 feet and 4 feet.
It would.
No, it won't. And you know how so what Brandy is saying is she's going to make Austin, who's a physics student of mine, like throw things and do experiments with her. Yeah. And you know how he knows it's going to land perfectly? You know how he knows it's going to hit that thing exactly? He understands parabolas. Like I taught him this a long time ago. By the way, just to let you know, well, this is actually when so Austin is this student and he's really good at math. I think he's one of the best math students in our school. But and I was actually when I first came to teach at Myron B. Thompson, he was one of my first students. I was teaching him this class, Algebra 1B. So just
The best class.
just letting you know, like Algebra 1B is where he started when I taught him. And now he's really good at calculus and whatnot. Actually, he's not in calculus. He's in trig or pre-calc or whatever. I'm not sure. Anyway, talk to you guys later. You guys take care. I'm all done. I got 10 minutes to finish my lecture, so I'm kind of stuck on that one, but whatever. All right. See you.